There are a number of reasons why you want to calculate the GCF or the least or the LCM in a problem. The most important thing when you're trying to figure out how to calculate these numbers is just kind of lay the numbers side by side. So in this example here, we want to find the factor that these two numbers share. And how you do that really is a number of ways. What I did here was I said, okay, I want to know what factor is the biggest that I could find that these two numbers share, 12 and 36. So what I did was I said, okay, what numbers can I multiply together to arrive at 12? And what numbers can I multiply together to arrive at 36? And I found these numbers. 1 times 12 gives me 12. 2 times 6 gives me 12. 3 times 4 gives me 12. 4 times 3 gives me 12. 6 times 2, 12 times 1, 12 times 2 gives me 24, and 36. So I took 12 and I went through and I just identified, if it's taking 12 and I say 12, 24, 36, 58, so forth and so forth. And I could continue on ... But I stopped because at some point you don't have to go too far because you're trying to find the greatest number that both these numbers share. Did the same thing with 36. And again, these are the numbers that if you divide them into 36, you would come up with an even number, a whole number. So 2 times, a number, 2 times 18, I believe it is, gives you 36. 3 times 12 gives you 36. 4 times 9 gives you 36. 6 times 6 gives you 36, and so forth. And when I take these numbers and I look at them side by side, I want to find the smaller number or the bigger number. In this case, I'm looking for the GCF. So what's the biggest number that these two numbers share and that's 36. So that's the big number. So 36 is going to be my least common multiple. Now, when I'm looking for the GCF, which is what is the biggest number that these two share, or factors that these two numbers share. Now, again, it's not a multiplication thing here. It's just a matter of me finding out what two numbers that these two numbers share when you do a factor tree. And the number here is 12. Now, I think it's an easier way to find the LCM, and that is going to be taking the two numbers, multiplying them together, and divide by 12. Or dividing by the smaller of the two numbers. Real quick and easy. You can use your calculator to do it. So if I want to find the LCM for any number, and I don't want to go through this crap, I just take the two numbers, multiply them together, and divide by the smaller number. Very, very straightforward, and often give you the right answer. But let's look at it another example. What if you have a number that's a prime number, and you have a number that is a number that's not a prime number, non-prime number? How can you find the GCF and how can you find the LCM? Well, the first thing is the GCF is, if you can't find the factors that these things have in common, then what do? How do you do it? You kind of do it the same way here. You just take these two numbers, multiply them together, and I find the GCF is 20. Take the two numbers, multiply them together, 4 times 5 gives you 20. So my GCF in this case will be 20. So when we're trying to find the least common multiple of numbers, and we're taking out how can we easily identify whether or not there are commonalities. So I've got two numbers here, 4 and 10. Both are even numbers, so you're going to see a lot of multiples here. And if you just count by 4s straight across, you can easily find the smallest number and the largest number. So I counted by 4 here. I said 4, 8, 12, 16, 20, 24, and all the way down the line. Did the same thing for 10. I multiplied it by 10. 10, 20, 30, 40, and so forth. And I would find here I have 20, and that's my LCM. That's the lowest common multiple. But then what is my GCF between these two numbers? Here it is, 60. These two numbers have 60 in common. So if you're looking at numbers and you know how to count by 5s, you know how to count by 4s, you can easily find the lowest common multiple just by taking 4 and just say 4, 8, 12, 16, 20, and so forth. And you can see side by side how these two numbers can identify easily a common multiple, a least common multiple, and you can find a number that the biggest number that these two numbers are divisible by, in this case 60. So you have a number of ways to do it. It just depends on how you understand it. My personal opinion would be, if I'm trying to find the GCF of a number that's under 60, doing this is easier, meaning taking 60 and add 60 and double it and so forth, or taking 4 and just multiples of 4. 4 plus 4 plus 4 plus 4 plus 4 plus 4, as I did here, or 10 plus 10 plus 10 plus 10 plus 10. So this becomes quite easy depending on the numbers that you're looking at. 4 works well, 10 works well, 2 works well, 3 works very, very well, because you can count by 5s, you can count by 3s, you can count by 4s, you can count by 10s very, very easily, and you don't have to do a whole lot of calculations to define out what the GCF and the LCM is. It becomes a little bit trickier when you're dealing with numbers that are kind of prime numbers in a way. So counting by 5s might not be too bad, but 15 might be a little harder. But let's do it. So we want to find the LCM for 5 and 15 and the GCF for 5 and 15. How do we do it? I did it like I did before. Count by 5s. 5, 10, 15, 20, all the way to 85. Did the same thing with 15. Count by 15s. 15, 30, 45, 60, 75, 90, and 105. And then I started to see what numbers are the same on both sides. Identified 45 and identified 75. So 75 is going to be my greatest common factor. And my LCM in this case is going to be 45 because they both share. And another way to find it easily is just to take the two numbers here, 5 and 15, multiply them by each other, and you get, in a sense, the GCF. So if you find the GCF, you can always back into finding the LCM. So I think this is probably the trickiest part of your quiz, but I think if you can follow either one of these strategies, you might do well. Again, when you want to find the LCM, the quick and easy way, take the two numbers, multiply them together, and divide by the smaller number. Plain and simple. Or you can take these numbers and you just take, what are the factors of 12? You can say 12, 24, 36, 60, and so forth. Or you can say 2 times a number gives you 12. 3 times a number gives you 12. 4 times a number gives you 12. Those are good ways also to find factors that exist between numbers. And so there's 2 ways to do it. So think about it. See what works well for you. But this is probably a really good exercise. I would suggest taking 2 different numbers. One is a prime number and one is a non-prime number, and see if you can use these strategies to get the right answer. Talk to you later.